Welcome back. Here is the sine rule, and we will start with an opening problem. These opening problems are usually good because they give you an indication of the sort of stuff expected out of you. So here is the opening problem. Okay. This is also related to a past paper question. An isosceles triangle has a base of 20 centimeters and a base angle of 68.2 degrees as shown. Find the length of the side x, y, and xz. So of course, if you do not know this already, for some of the students, one of the things that might be hitting your mind right now is what do we mean by an isosceles triangle, but we'll see that shortly. Okay, so the results, before we solve the question, let's see what the sine rule is. Now, we found from the area of triangle rule that given a triangle such as this, we can find the area by saying a half b times c sine of a, because that becomes the included angle for b and c. The included angle for a and b is c. The included angle for a and c is angle B there. So therefore we can find the area using a half BC sine A, or half AC sine B, or half AB sine C. So these are the results we found for determining the area of a triangle. Okay, so all those three formulas are referring to the area of the same triangle, so they are equal. Okay, if we multiply everything, we remove that area bit, and then we multiply everything by a half, we can get rid of the half, and then we divide by lowercase a, b, c. So multiply through by 2 to get rid of the half, and then divide by a, b, c. If you do that, you should end up with this formula here, and that's it. This is what we refer to as the sine rule. Okay? So the sine rule is just an extension from the area of a triangle rule. Okay? So how do we make use of the sine rule? Okay? When do we need the sine rule? Okay? All right. So we go to the problem. We use the sine rule when we are given two angles. We are given two angles on one side, and we are being asked to find the other angle, or we are being asked to find the unknown sides. Okay? Or we know two sides, and we are being asked to find the other side or the other angles. So to use the sine rule, we must know two sides and an angle, okay, or two angles and a side, okay? For example, here is a case where we know we have been given two angles and one side, so that's the case A, two angles and one side given. Or the second case where we are given two sides and an angle, all right? So when we have this, we can then work to find the other two unknown angles as well as the unknown side, okay? In this case, it is straightforward to find the third angle here because we know two angles. The sum of angles in a triangle is 180, so that's not difficult. But then we would need to know the unknown side, to find the unknown sides, this side and that side. So when we have scenarios like this, then the sine rule becomes really useful. Okay? Okay. With this knowledge, we can now go and solve the problem, the opening problem, for example. Here is an example 1. Find angle ACB and the length of the side X and Y. So here is a triangle. We know we've been given two angles and one side. So clearly this is a case where sine rule becomes useful. We want to know the angle ACB. So angle ACB is this angle here. We also want to know the length of X and the length of Y. This should not be very difficult, as we'll see. So just keep in mind the sine rule. So part A, the sum of the interior angles of a triangle is 180, and since this is 40 and that is 70, that's already 110. So how much do we need to make 180? We need 70 degrees, right? We take 180 and subtract this 2, which is 110, and the result is 70 degrees. So part A is done. Part B of the problem, we want to find the value of x. So by the sine rule, we know sine of, so we know two angles, right? It is easier to find, we can find any because now we have all the three angles. Even if we didn't have one of the angles, it's still fine. So we can now say, since we know at least one angle and it's the side that is opposite, well, sine of ACB, sine of ACB, sine of this angle divided by that side must be equal to sine of this angle divided by that side. So sine of ACB over AB, so ACB is this one, over AB must be equal to sine of ABC over AC there, okay? So if we write that down, we substitute the values that we have, we get sine 70, okay, over x must be equal to sine 70 over 2.5. This should be clear, all right? Sine 70 and sine 70, this already tells me that x has to be 2.5, all right? So I don't need to go any further. X is 2.5 units or centimeters, whatever it is that the triangle length is measured in. That's the length of x, all right? What about y? So we now know that is 2.5. The angle is 70 there. Now what about y? Similarly, by sine rule, we can find y now. Sine BAC, that means sine of 40 over y must be sine ABC over 2.5. All right, so sine 40 over y must be sine 70 over 2.5. If we rearrange that formula, we have that and use a calculator. And if we work that out, we get y to be 1.7 units, centimeters, meters, whatever it is. Yeah? Okay. So that should, hopefully that wasn't very difficult. Let's see if there's another one. Solve problem number 2. Okay. Find the length of side x and the angles alpha and beta. All right. So now we know the length of two sides. This is the second case. We know the length of two sides and one angle is given, and we want to know the other two angles. We also want to know the unknown side x there. So again, we just make use of the sine rule. So we know sine of 32 divided by 3 must be sine of alpha divided by 5, which must also be equal to sine of beta divided by x. As simple as that. All right, so we can start by looking for sine of alpha. So we just need this first ratio and the second ratio there. Okay, let's deal with that only. So if we do that, we make sine of alpha the subject of the formula. Use your calculator to work that out, or directly go and look for the sine inverse. Either way, you're using your calculator. That stuff inside the bracket, I think, gives us alpha as being 62 degrees. I'm hoping that you know how to use the calculator to do this. All right, maybe in the subsequent problems we will try to use a calculator, but hopefully that is not very difficult. So alpha is therefore 62 degrees. Based on the triangle, it might not look like alpha is 62 degrees, but well, the triangles given to you are never really to scale, okay? So that should not worry you. So alpha is 62 degrees, and if alpha is 62 degrees and that one there is 32, we can easily get the value of angle beta by the same rule about the interior angles of a triangle. Okay, so by interior angles of triangle, we have 180 minus 94, the sum of those two. Okay, and that gives us angle beta as 86 degrees. And now that we have angle beta, it should be possible to find the unknown length x. Okay, all right, so the last part by sine rule there. Now we know that angle there is 86. Okay, if we make x the subject of the formula, we have 5 sine 86. 5 sine 86 divided by sine 62. We are looking at the second two fractions there, or two ratios, and if we use a calculator for that, it gives us the length of side x as 5.65 units. Okay? Yes? Okay. Now we solved the opening problem. All right, so this was our opening problem. We want to find the unknown side xy and xz. All right, but the problem is that we only have one side. That angle is 68.2. We are given one angle and one side, but we say that we use the sine rule when we have two angles or two known sides. So what's going on here? Well, this is an isosceles triangle. And what is an isosceles triangle? Okay, so we ask what's an isosceles triangle there. And Mr. Sharp guy there says an isosceles triangle is one with two sides of equal length. All right, so we can see that we have two equal lengths there. And if these two sides are equal and we join them with a side YZ there, then the base angles there must be the same. So if this is 68.2, then this also has to be 68.2. Okay, and because we know that is now 68.2, now we know we have been given two sides, we can find that angle as well if we didn't know it. Okay, the sum of interior angles is 180, and that's 68.2. 68.2, if we multiply by 2, we get 136.4, and if we subtract that from 180, we get 43.6. So we know that angle up there is 43.6. All right. Now, with the knowledge of all three angles, it should now be possible to find both sides x, y, and xz. And because they are equal, we only need to find one of them. And we reason using the sine rule. Okay, we will keep that in mind. The top angle there is 43.6, and the bottom angle, the two of them, is 68.2. So by sine rule, now we can say sine of x, angle x up there, over yz, which is 20, must be equal to sine of z, which is 68.2, divided by the side xy. If we substitute in, there we go. And so the side xy is 20 sine 68.2 over sine 43.6. All right, put that into, pump that into your calculator, and we should get the length of side xy as 26.9. And because xy and xz are equal, xz is also 26.9 centimeters, all right? And that is to three significant figures. Notice the use of that symbol there. It's important, especially for IAs and in questions like this, all right? I'm going to hope that we've understood this. This brings us to problems that you should try now. Okay, so here are two examples of questions you should try. All right, find the unknown sides in each diagram. Okay, that's question one. There is another one, I believe. All right, find the unknown angles and side lengths in each diagram. So there are two more that you should try. You're looking for the unknown angles there, angle theta, and you're also looking for the length x and y. Okay? Yeah, and this brings us to the end of the discussion on the sine rule. We will eventually be using all the rules together to solve real-life problems, but that's the end of the sine rule. We will next go to the cosine rule. All right? Thank you very much.